Namaskaram. So let's start with Vedic Maths today. What is Vedic Maths and how it is useful for doing a day-to-day calculation in a much faster way will be explained to you in this sequence of sessions. And what is the sequence of the sessions? We will be doing 16 different sutras and 13 different sub-sutras level by level with you in these sequence of sessions. Okay. In every sutra, there are at least one or two applications that we will be discussing with you. Today, the agenda is going to be Sutra number 1 and application number 1 of the same. What is Sutra number 1? It is Ekadikena Purvena, and the Sanskrit way of writing it is already written in front of you. Okay, this is the first sutra. So you will ask what it actually means. So it actually means the English translation of this particular sutra is by one more than the previous one. What does that mean? It basically means next one. It means next one. Okay? By one more than the previous one. So if the previous one is 7, then what is the next one to it? By one more than the 7 would be 8. So this is what do we mean by sutra number 1. And now you must be thinking how to apply it. The first application of this is finding the squares of any number ending with 5. Okay? For example, if I need to do the square of 15, all you needed to know already, that is, what is the square of 5? The square of 5 is 25. I am very sure this much most of you already know. What is square? That also you should understand. If I add 5 multiple times, for example, I am adding 5 4 times. That means 5 into 4. So addition done multiple times is called multiplication. And multiplication done multiple times is called power. So 5 when multiplied by 5 times is 5 square, and that is what we mean by square, and that is 25. So this is one prerequisite to solve this particular sutra. I hope this all of you already know. Okay, so how do we do the square of 15? I'll just do the square of 5, which is 25, and write it, and then all the digits before this 5, I will apply Ekadikena Purvena to it. That means 1 is a number. So 1 is the previous one, right? 1 more than the previous one would be 2. So 1 more than 1 would be 2. So 1 into 2 is going to be 225, which is the method of calculating the square of 15. Next application, not application, then one more example of the same thing. The square of 25, yes, you guessed it right. 5 square is going to be 25, and then applying Ekadikena Purvena to 2. 2 being the previous one, I'll multiply that 2 with the 1 more than 2, that is 3. So 2 into 3 is going to be 625, and that is what the square of 25 would be. I am very sure now every one of you will be able to calculate all these things in finger clicks. Let's apply. The square of 85. I will not be using a pen and paper. I will just be doing it mentally. How? The square of 5 is going to be 25. We'll write it here. 8 is the previous one. The next number, one more than 8, is going to be 9. So I'll multiply 8 by 9. 8 into 9 is going to be 72. So 7225. That means 7225 is the square of 85. Isn't it interesting? I hope it is. Right? So 5 square, 25. 8 multiplied by the next number to that is going to be 7225 is going to be your answer. 115. So I am actually doing this particular question for two reasons actually. One reason I wanted to make you understand that it's not like that square of only 2-digit numbers you can find using this logic. You can also do it, do the squares of numbers of 2-digit, 3-digit, 4-digit, n number of digits you can solve by the same logic. Okay, so let's apply. 5 square is going to be 25. Applying ekadikina purvena to 11, that is 11 being the previous number, I'll multiply 11 by 12. That is going to be 132. Now you will say that I already know the multiplication of 11 and 12. No, I did it on the spot. How? This is the food for thought that I'm going to discuss with you in today's session as well. Now, what is a food for thought? If I need to multiply any number by 11, that is very easy. How? Let's say the number is 42, the number is 53, the number is 67, and I need to multiply these numbers by 11. How to do that? Just write 4, which is the first number, just write 2, which is the last number, and in the middle, just do the summation of 4 and 2. That is going to be 6. So 462 is the multiplication of 11 and 42. Isn't it interesting? Yes, it is. Now, using the same logic, here also 5 and 3, and in the middle, I'll be writing the addition of 5 and 3, that is 8. So 583 is going to be your answer, right? Now, something interesting here. So 6 and 7 you will write just like you did in the earlier two. Now, in the middle, will you write 6 plus 7, which is 13? So, will the multiplication be 6137? No, it won't be. What you have to do? You have to write 6, you have to write 7, and in the middle, you have to write 6 plus 7, 13, but in a different way, because only a single digit can come here. But we have 13, 2 digits. So, what we will do? I'll write 3 and take 1 carry. That is, 6 plus 1 would be 737. And that was the food for thought I needed to discuss with you before moving to the next concept. Okay, so I hope you will be applying these methods in your day-to-day life, right? So we will be joining the next session. In the next session, we'll be doing a lot of practice questions, making you understand the application and how you can do such calculation in finger clicks. Thank you guys. Dream big, achieve bigger, make us proud, and let's go and crack any examination that you are preparing for. Thank you. The Sutra number 1, as you already know, is ekadikena purvena, which means one more than the previous one. Okay? And we have already done this. Now, if I need to do the square of 225, how will I be able to do that? See, the square of 5 is going to be 25, right? Now, I need to multiply 22 by the very next number to 22, that is 23. Now, I'll make you understand how to do this calculation in your mind. See, you have 22 into 23, okay? Now, I have already taught you how to multiply any number by 11, right? So, if I take out 2 from 22 and give it to 23, that means here I am left with 11 and here it is 23 into 2, which is 46. So you have to multiply 11 by 46 now. I'll just explain by writing also, don't worry, okay? So I needed to multiply 22 into 23. So I wrote 22 as 11 into 2 into 23. Now I did 11 into 2 into 23, which is 46. This is what I was telling that you need to do from the next time in your mind. Okay. Now write a 4, write a 6, and in the middle write the summation of 4 and 6, which is 10. How you have to write it? Not 4106. You have to write 1 in the carry, 0 here. So it would be 506. Right? So the answer to this particular question would be 50625. I hope it is very clear in your mind properly. Okay. Now 325, using the same logic, 5 square 25, the multiplication of the previous one here by the next one, by one more than the previous one, that is 33, right? So how do we do that? See, 32 into 33 we have to do using the same logic. Write 33 as 3 into 11. Okay, 11 you have got, 3 you have to multiply by 32, right? So 3 into 32 would be 96, right? I'll just write it one last time for you, okay? So 32 into 33 you have to do. So writing this 33 as 3 into 11 and then multiplying 32 and 3. 3 2s are 6, 3 3s are 9. So 96 into 11 you have to do, right? So what would that be? It would be write a 9, write a 6, and 9 plus 6 is going to be 15. So write 1 carry and 5 in downwards. Okay, so 9 plus 1 is going to be 10. So the answer here is going to be 105625. See, the square of 325 we were able to do in just a finger click. As of now, what I taught you, the multiplication of any number with 11. But those numbers were 2-digit numbers. Now, I'll make you understand the multiplication of any 3-digit number with 11. How to do that? Let's see. See, if the number is, let's say, 234 by 11. How will I do that? I'll write the extreme numbers. I'll write a 2. I'll write a 4. Here, I will do the summation. I'll take I'll take pairs of 2 from backwards. That means 4 plus 3 is going to be 7. I'll write it here. Then 2 plus 3 is going to be 5. I'll write it here. Now there is no more availability of pairs of 2. So I'll just do this and say this is my answer. So 2574 is going to be your answer. Just check it. It is right. Okay. Now one more. 732 multiplied by 11 using the same logic. Okay. Write a 7, write a 2. The extreme numbers you have to write. Now take pairs of 2. So 3 plus 2 is 5. I'll write it here. 7 plus 3 is 10. So 1 carry and 0 here. So this would be 7 plus 1 would be 8052 would be your answer. I hope it is crystal clear to every one of you, right? If I needed to do for a n-digit multiplication, that means any number of digits are there. For example, the number is 321435116. Okay, and this I have to multiply by 11. Just see, will I be able to do that? Yes, I will be. Write a 3, write a 6, extreme numbers. 6 plus 1, 7. 5 plus 1, 6. 5 plus 3, 8. 3 plus 4, 7. 1 plus 4, 5. 1 plus 2, 3. And 3 plus 2, 5. So the answer to this is going to be 353578676. It was a very lengthy calculations, and just imagine how beautifully and how creatively you were able to do in finger clicks using Vedic Maths, right? So that would be all for today's session. In our next session, we'll be doing a lot of practice questions. Till then, dream big, achieve bigger, make us proud, and let's go and crack the examination you are preparing for. Hello and welcome. This is going to be the last session on Sutra number 1, application number 1. And what we will be doing today? I am giving you some practice questions and I'll be giving you around 3 to 4 seconds to think about it. Okay? And then we'll be doing these questions as well. Find the square of the following: 35 and 95. How to do that? Just 1, 2, 3, 4, 5. 5 seconds I have given to you. You should have written the answer by now, right? So 5 square, 25, 3 into the next number, that is 4. So the answer would be 1225, right? Similarly, for 95, 1, 2, 3, 4, 5 seconds. So 5 square 25, and the next number to 9 is going to be 10. So 9025. Next time onwards, I'll be giving you 4 seconds now. Okay? Starting with the next question. 45. Do the square of 45. 1, 2, 3, 4. And from the next time, I'll not speak also. Okay? It is going to be 25, and 4 into the next number is 5. 2025. Right? Do for 1024. 105, sorry. Yes, it is 11025. 10 multiplied by the next number to 10, that is 11. So 11025. Isn't it beautiful? 55. Yes. 5 by the next number to 5 is 6. 5 into 6 is 30. 3025. Right? Now 135. 135 multiplied, I'll give you more seconds to it, but because this is the second application, or I should say the second sutra, so as of now I'll do the basic method, and from the next class I'll be teaching you the product of 13 into 14 in a very fast way. Okay, so 5 square is going to be 25. 13 into 4, for 13 into 14 you have to do. So do by the basic method as of now only. Okay, 13 into 14, what would that be? 13 4s is 52. 5 carry. 13 1s is 13 plus 5 is going to be 18. So 18225. Okay, so this is the application of sutra number 1 for you. Okay, just do for these two as well. 65. Yes, 6 into 7 is going to be 42. So 4225. This is simple, right? 195 square. 19 multiplied by the next number is going to be 20. So 19 into 20 is 380. So 38025 is going to be your answer. Do this as well. Yes. 75. 7 into the next number is 8. So 7 8s is 56. 5625. Right? 215 square. I gave you 10 seconds. Why? Because I wanted you to think. Okay? So 5 square was 25. 21 multiplied by the next number to 21 is 22. Take a 2. Give to 21. It is 42. Now do the product of 42 with 11. So it would be 4 and 2, and in the middle it would be 4 plus 2, 6. So 46225 is your answer. Right? Now, some more practice questions are there for you to do yourself for the multiplication with 11. Just let me know if any of this calculation is difficult for you. Okay, I'll just do some of them for you. For example, 135 into 11, I'll write a 1, I'll write a 5, 3 plus 5, 8, 3 plus 1, 4, right? Here, 75, okay? Write a 7, write a 5, 7 plus 5 is going to be 12. So 1 here, 2 here. 7 plus 1 is 8. So 825 is your answer. The rest of the ones, I expect you to do yourself. Okay, guys? So this was the second session in which we did Sutra number 1, application number 1 completely for you. Okay? Let's meet in the next session with more zeal and with much better methods. Okay? Till then, dream big, achieve bigger, make us proud, and let's go and crack the examination you are preparing for. Thank you, guys. Welcome back, guys. What was Sutra number 1? Just to remind you, Sutra number 1 was Ekadikena Purvena, which means by one more than the previous one. Okay? And this is a second application. And what is the prerequisite to be able to apply this particular thing? The second application is finding the product of numbers. And what is the condition? That all the unit digit numbers should be having a summation of 10. And apart from the unit digit, whatever is there in the tens place, 100 place, or even the thousands place, it should be the same. Okay. For example, if I say a number is 17285372, okay, and the second number is 17285378. So here Ekadikena Purvena would be applicable. How? Because the unit place is having a summation of 10. Right? 2 plus 8 is 10. And all the other digits in both of them are same. So just to explain to you that here Ekadikena Purvena would be applicable. Right? Now, what more to do? Let's see, and what is the procedure to solve this particular kind of questions. Okay, so I'll take an example of 27 into 23. Here 7 plus 3 is 10, so the prerequisite is fulfilled, first part of it. And obviously the second part is that every other digit is the same, 2 is the same. Okay, so the first part would be doing the unit digit into unit digit. And what would that be? 7 into 3 is going to be 21. So you'll write 2 and 1 here. Simple. The next step to it would be multiplying 2 by the next number. This is the number and this is the previous one. We have to do one more than that. So 2 plus 1 is going to be 3. So 2 into 3 is going to be 6. So yes, this is your answer. Simple as that, right? Now I'll do one more application for you so that you can understand it, right? So let me take a very simple example. Let's say I'm taking 18 into 12, right? How to do it? 8 into 2 is going to be 16 and the previous number is 1 and 1 getting added by 1 means 2. So 1 into 2 is going to be 2. So 216 is going to be your answer. I hope you were able to understand the application of this. Okay, we will be doing a lot of more questions on this particular thing in our next video. Till then, dream big, achieve bigger, make us proud, and let's go and crack the examination you are preparing for. Hello and welcome back. This is going to be our fifth session on Sutra number 1 and the application number 2 of it. And we are going to do a lot of practice in this particular session. Okay. So what was our Sutra number 1? Ekadikena Purvena, which means why one more than the previous one, right? When the second application says that the sum of the digits at the unit place should be equal to 10 and all the other places should have exactly the same digits which are there in the previous one as well, in both of them basically, right? So the application says if I have to do a multiplication of 34 into 36, I need to check that the unit digit, the summation is supposed to be 10. Yes. So is it 10? Yes, it is. And the rest of the digits are same? Yes, they are. So what you need to do? In two places, you need to write the product of 4 and 6, which is 24. And in front of that, you have to apply Ekadikena Purvena, wherein the previous one would be this 3 and by one more than the previous one. So 3 plus 4 is going to be 3 plus 1 is going to be 4. So that means you have to multiply 3 by 4, which is 12. So 1, 2, 2, 4 is going to be your answer to this particular question. Isn't it easy? I hope it is. One more application, 42 into 48. So 8 into 2 is going to be 16 and 4 into the very next number is going to be 5. So 4 5s is going to be 20. So 2016 is going to be your answer. See, in seconds, with finger clicks, we were able to solve such questions, right? I'll just explain once more. I checked that 2 plus 8 is 10. So I just multiplied 2 and 8, which comes out to be 16, and I have to place it in 2 digits only. Okay, and the rest of the digits I saw, they are same. So I can apply ekadikena purvena here, which means I'll just multiply 4 by the next number to 4, which is 5. So 4 into 5 came out to be 20, and thereby the total answer was 2016. One more application for you guys. I hope you are able to solve now yourself, right? Answer is 1 into 9, but I asked you to do in 2 places. So how will you do that? Firstly, you will not be able to apply this particular application to here. Why? Because though the summation of 1 and 9 was 10, but the previous digits to them were not the same, guys. So you cannot apply ekadikena purvena. But yes, you can apply something else here, which is 50 plus 1 into 50 minus 1, right? Can I write 51 as 50 plus 1 and 49 as 50 minus 1? So you already know that a plus b into a minus b, what is that? It is a square minus b square, right? So here if you apply that, so 50 into 50 is going to be a square, that would be 2500, minus b square plus 1 and minus 1, that means the value of b is 1, minus 1. So the answer would be 2499. See, I did apply something else here, but I was able to explain to you 2 things. One, that you always have to check that the sum of the digits should be equal to, the sum of the digits should be equal to 10, right? And the previous digits should be the same. If they are not same, you cannot apply ekadikena purvena here, okay? Now, I just want to explain one more thing to you, that it's not always that you can only apply for 2-digit numbers. You can apply for 3, 4, 5-digit numbers, anything you can go for, okay? So, the summation of 4 and 6 is 10, yes, and rest of the digits are same, that is 10 and 10. So, you can apply ekadikena purvena here as well, okay? So, 4 into 6 is going to be 24, and apart from that 10 is there in both of them, so you need to apply ekadikena purvena here and get the answer as simple as the 2 multiplication used to be there, right? So 10 multiplied by the very next number to 10 is going to be 11, and 11 into 10 is 11024, right? One more application, 102 into 108, okay? This is very simple, right? The summation of these two is 10, so 8 into 2 is going to be 16, and 10 into 11 again 11016. If it was 112 or 117 into 113, then also the same logic would apply. 7 into 3 is going to be 21, and 11 multiplied by the very next number to 11 is 12. So that is going to be 132. So 13221 is going to be your answer, right? Now let's do one 4-digit number multiplication. So 9 into 1 is going to be 9, and 100 is common in both of them. So 100 multiplied by 101, which is going to be 101 and 2 zeros. But here 9 into 1 was 9, but we needed to do in 2 places, so 1 more 0 would be there. That is the only thing you need to be taking care of, okay? So one last, wherein we'll be using some other number than 1 in the as being the first place, okay? So 6 plus 4 is going to be 10, so we can apply this logic here. 6 into 4 is going to be 24, and 20 when multiplied by the next number, which is 21, is going to be 21 2s is 42, and 1 more 0. So 42024 is your answer, okay? So now I am going to give you some self-practice questions whose explanation I'll be doing in the next video, okay? So please try to solve all these questions, and in the next video we'll be doing the solution of them. Thank you guys. So now we are left with one more very important application of Sutra number 1, which is ekadikena purvena, okay? So what is that application? That application is converting fractions into decimals. Okay, as of now we have taken up addition for you, multiplication for you, and subtraction for you, but one more application is left, which is division. And this is just like a starting of how Sutra number 1 deals with the division part of it. Okay, so but there is one particular thing you need to remember by, that this fraction to decimal can be converted for only a denominator which ends with a 9. Okay, before 9 anything can happen, but it should end with a 9 always. Okay, so as you already know that Ekadingana Purvena means by one more than the previous one. So whatever comes previous to 9 is called the previous one. So here x would be called the previous one. And what do we do with the previous one? We add it by 1. Why? Because it says by 1 more than 1 plus more than the previous one. Okay, so whatever comes, we have to divide it by y. Okay, so we'll take y here, and whatever is x plus 1, we'll keep it here. But here the division is not just a regular division. Okay, the division is also very special. The major kind of fraction that we use here is always a proper fraction. What is a proper fraction and what is an improper fraction? Proper fraction means if numerator upon denominator is written and the numerator is lesser than the denominator, such a fraction is called a proper fraction. And obviously you guessed it right, if the numerator becomes larger than the denominator, then it is called an improper fraction. Okay, so Ekadikena Purvena hereof only deals with proper fraction. Okay, so let me take, this is all theoretical part, let me take the practical part of it. Okay, so as you already know that the English translation of Ekadikena Purvena is by one more than the previous one, and how it is useful I've just explained to you in totality, right? So the application says finding the decimal value of the fractions with denominator ending with 9. Okay, let me take a very simple example. Let me take 3 upon 19 here. I have specifically taken all the 3 digits to be separate so that there is no confusion at all for you. Okay, is the denominator ending with a 9? Yes. So what is the previous one? 1 is the previous one. So by 1 more than the previous one came out to be 2, and this 2 is supposed to get divided by 3. Okay, because I mentioned it is a proper fraction, that means the value would be lesser than 1, right? That means it will always be starting with a 0 point something, right? So 0 point is something you need to write anyways. Okay, then you will write 2 ones are 2, the difference would be 1. Till here the division is just like a regular division, but after coming forward from this, the division would be separate from the regular division. Okay, how? Let me tell you. Every single time you have to copy paste whatever comes in the quotient and place it next to 2. Okay, so 2 5s would be 10. Again remainder 1 come. Now what will be placed aside this particular remainder? The quotient which has just come. So it would be 15. So 2 7s is going to be 14. Remainder 1. 2. Now what will come? 17 will come. 7 will come, I mean. So what would it would be? 8. Then 16 would come. Again a 1. Okay. Now again 8 would come. So it would become 18. Right? 18 when divided by 2 would make it 9. Right? So that would be 18 again. 0. Now what would get copy pasted? 9. So it would be 4, 2 4s are 8, remainder 1. Now 4 would get copy pasted, 4, right? So 7 will come, 14. If 0 comes, you don't have to stop, you'll keep on doing it, okay? But I feel so that this is something which is sufficient enough for you to solve, because you don't have to do a PhD kind of a thing on Vedic maths. What you need to do is, you need to understand and better your calculations. If you are even able to find, using such methods, up to 2 digits, 4 digits, that is more than sufficient for you. Okay, so I'll be teaching you up to that particular level only, right? Let me take some more examples for you. If it is something like 7 upon, I've just taken 19, right? So let me take 7 upon 29. Okay, so what would that be? The previous one here is 2 plus 1 by 1 more than the previous one, that means 3 here, and 3 is supposed to get divided by 7, right? As I already told you, 0 point is something which is supposed to come, okay? After that, what will come? Let's see. 3 2s is going to be 6, 1 here, 2 will get copy pasted here, 3 4s is going to be 12, 0 here, then 4 will get copy pasted here, right? So 3 1s would be 3, 1 will be coming here, again 1 will come, so 11, so 3 3s is going to be 9, 2 here, right? Now 3 would get copy pasted here, 7s is going to be 21, 2 would come, again you have to take a 7, so that would be 27, and 9 would come. Again I am saying this would come, go on and on and on. But what you need to do is, you just need to ensure that you have got the correct calculation up to 2 digits or 4 digits, something like this. Okay. If you have got that particular part, I am very sure you don't need to do anything special after this. Okay. Right. Now, let me take one more example just to make it clear in your mind. Okay. Let me take 5 upon 39. Okay. So, what is the previous one? 3. By 1 more than the previous one, that means 4. 4 has to get divided by 5, but 0 point will always come because it is a proper fraction, right? 4 1s would be 4. 1 comes, 1 would get carry forwarded. 2s would be 8. 3 would come. Now 2 would come because 2 is the quotient here, and 4 8s is 32. 0 would be here, but 8 would come. 4 2s would be 8. Again 0 would come. 2 would get carried. Now here is something special, because 2 has come, and even after taking what? Even after taking the part from the quotient. So you have to put a 0 here in order to get 20 here. Okay. So 5 would come, and again 0 would come, and then so on and on and on. It would keep on going for you. Okay. One thing I want to teach you here, which is something special out here, which is when 20 comes here and 0 comes, then you take the quotient as 5. Just see what is the special thing happening. This is also 5. This is also 5. So do you actually feel anything would be different after this? No. That means 5 upon 13 is a recurring decimal. Okay, that means what? The answer to this would be 0.128205, 128205, 128205, and so on and so on. That's why it is also at times written as something like this. Okay, so this was something special, and the reason why I took this particular fraction was this only. Okay, so this was another application of Sutra number 1 which I wanted to discuss with you. Okay, so that would be all for this particular part. Thank you guys.